we are solving right triangles. We're looking at the trigonometry of right triangles. So every right triangle has a 90-degree angle. And that angle that is formed, I'm going to draw the angle right here. That angle has two parts to it. One side of that angle of theta is called the hypotenuse. I had a student last year, you guys remember Ella Bordeaux? Ella accidentally called instead of the hypotenuse, called the hypothalamus. So, what's the hypothalamus, anybody?
It's in your brain.
Yeah, it's the part of your brain. So I was going to try. What's that part of the triangle? The hypothalamus. That was funny. So
I'm gonna tell her.
Yeah, you do. You tell her that.
Can I text her?
Yes, please do. I remind her quite often about it. The next side is the adjacent side. The word adjacent means next to. Okay, next to. So it's the other side that's next to the angle, and then the other side is the opposite. And opposite means it's across from the given angle theta. Okay? So we define sine of theta to be the opposite divided by the hypotenuse. And we define cosine to be the adjacent divided by the hypotenuse. And we define tangent to be the opposite divided by the adjacent. And so a lot of students memorize. I didn't learn this when I was in high school. People wonder how that happened, but I didn't. There's this thing called SOHCAHTOA. Yeah, right? It's kind of neat. You know, you got opposite and hypotenuse, that makes sine. Adjacent and hypotenuse makes cosine. And opposite and adjacent makes tangent. So there you got it. So we'll go to work. Find the exact value of the 6. We're not going to do 6. We're going to do 3 today. Trig ratios for the given angle theta in the triangle. We're also going to get rid of example 2. You guys don't need it because you're a shuba shuba shmat. So I'm going to list sine of theta and cosine of theta and tangent of theta. And then I'm going to look at this triangle and I'm going to identify the legs. And it's okay to be confused about this. I've had a number of students I needed help out today, make sure they get this right. But is 5 the opposite, the adjacent, or the hypotenuse?
Opposite.
It's the opposite because it's across from theta. So this is the opposite. About 13, is that the adjacent or the hypotenuse?
Hypotenuse.
This is the hypotenuse. And so notice you have the opposite and the hypotenuse. So is that going to be sine, cosine, or tangent? Sine is opposite and hypotenuse. So sine of theta is 5 over 13. And I want to write that ratio for 2 more of these. But if you notice, for cosine and for tangent, I'm going to need the length of the adjacent, won't I? How would you figure out the length of the adjacent side? The Pythagorean theorem. 5 squared plus b squared is 13 squared. Or maybe you remember the special right triangle sides. 12. Okay, thank you. So if you have forgotten these, it would be good for you to remember these. And I don't just say that for my benefit. This is something I've so as I put together curriculum, I make sure I look at all the standards of the ACT. And the ACT actually says it really wants you to remember all these. It doesn't, so actually it puts these kind of problems in there. So it wants you to know 3, 4, 5 is a special right triangle. It wants you to know 5, 12, 13. It doesn't want you to have to go through and actually do the Pythagorean theorem. You can, just takes more time. And do you get an unlimited amount of time on the ACT? No. So people will remember this. You got more time. It's a good thing. We also know that 7, 24, 25. And we know 8, 15, and 17 work as well. It also works out that any multiples of those work as well. So if you were to take and multiply each one of these by 2 to get, like, say, 16, 30, and 34, that's also going to work. So any multiples of those work. So I just listed the 4 most common, and that's what the ACT asks. So we know that this side is 12. And now I can list the ratio for cosine. Cosine is going to be the adjacent over the hypotenuse, which is what?
12 over 13.
12 over 13. And the tangent is going to be the opposite over the adjacent, which is 5/12. Are we okay with that? Okay, flip it on over. So now we get to kind of the point that you're going to be working on your assignment. We're going to actually work through example 3 here, and then you're going to take about 10 minutes to work on your assignment, and we're going to come back to kind of the bigger piece that we're doing today. But you should be able to solve for a missing side of the triangle. So if you look at this, we want to be able to find x. And instead of being given 2 sides, you're just given a side and an angle. And that's all you need in trigonometry. It's very useful that way. So I first want to label opposite, adjacent, and hypotenuse. Which side is x? X is the hypotenuse. How about 9? 9 is the opposite. So will I be using sine, cosine, or tangent?
Sine.
I'll be using sine. The sine of 42 degrees is equal to the opposite, which is 9, divided by the hypotenuse, which is x. Sometimes the variable goes in the top, sometimes it goes in the bottom, depending on how the triangle is set up. I like to write this over 1. I think it's easiest for people to just cross multiply. You notice 9 times 1 is 9. And then I have x times the sine of 42. And I'm going to then solve for x by dividing both sides by the sine of 42. So on my calculator, I have 9 divided by the sine of 42. And I get 13.45.
Yeah, I got that.
I got
Radians and degrees.
Oh, yeah.
Yeah, so in your options for mode right here, press mode, you're defaulting down to radians. If you go over to degrees, then you're good there. So now if you press the same thing, you're going to now get the correct answer.
Is that a dot or a minus sign?
Right there,
Yeah.
this is x times sine of 42, just cross multiplying. Yep.
Ella said, "Ha, no way. Happy to be of entertainment."
Love to laugh at Ella. Oh, Ella. All right, this one right here, we have a 90-degree angle. What is 14? Opposite, adjacent, or hypotenuse? And what is x?
Opposite.
X is the adjacent. Okay. So do we use sine, cosine, or tangent?
Cosine.
We use the cosine, namely that the cosine of 63 is equal to the adjacent, which is x, divided by the hypotenuse, which is 14. If I cross multiply, x times 1 is x, and then I get 14 times the cosine of 63. So notice in the previous example, we ended up dividing by the sine of 42, whereas in this situation, we're multiplying by the cosine of 63. It changes depending on the problem. So be ready for either. And I do 14, and then I'm going to multiply by the cosine of 63, and I get 6.36. Does anybody here borrow their calculator to a calculus student so that they can use it during calculus class? Because they stay in radians just about all the time. So it's not uncommon for trig students to come back and take a test and have many of the problems incorrect because they were working in the wrong form. So pay attention to that. Try the last one on your own. We should have 9.4 times the tangent of 27, which is, Gunnar, what do you got?
1.7.
There's so much more to trigonometry than what we're seeing right now. For example, these all have 90-degree angles, right? Well, what if they don't have a 90-degree angle? What if they have a 113-degree angle? You can still use trigonometry to solve it. There's lots of things that we can do. So this is just the basic kind of the fundamental foundation. We're going to do just this part right here. We're not going to do this problem, but just this part. And then you'll be set to start your assignment, start to figure some of those pieces. So sketch a triangle, and we're not going to find the other 5 trig ratios. We're just going to find theta. So wish I would maybe have changed the some of the notes here, but I can't predict where you guys are at. I see where you guys are at and what we need to do. I noticed that this is sine of theta is 3/7. I want to draw a triangle that's representative of that. And so I know sine is opposite over hypotenuse. So I'm going to draw a triangle that has a right angle. Again, everything today has a right angle in it. And I'm going to put theta right there. Okay. And so opposite is 3, hypotenuse is 7. So suppose you were given that triangle where the opposite side was 3 and then the hypotenuse was 7, and we said we want you to find the angle. Well, if you look at sine of theta is equal to 3/7, what we want to do is we want to find theta. And this is the only time I'm going to do this in class. You'll just start to get used to it after this. But we want sine to go away. So do we subtract sine? Do we divide by sine? Do we multiply by sine? The answer is no. We don't want the theta to go away. We just want this thing to go away. And I'll show you how we do it. Do you remember back in chapter 4 with logarithms? Do you remember when we had to say the natural log of e to the x? What happened in that situation? Those canceled out. You're just left with x, right? Because natural log and e are inverse operations. So in order to make sine go away, we need to do the inverse operation. So we do sine inverse of both sides. And look at what happens here. When you do the sine inverse of sine of theta, those cancel, leaving you just theta. And you're left on this side with sine inverse of 3/7. So your calculator has this special button. It's pretty cool. Notice how you have sine, cosine, and tangent. This is sine inverse. That's not 1/sine. This is what you use to find an angle. So anytime you're finding an angle, press sine inverse or cosine inverse or tangent inverse, and then you type in your ratio, 3 divided by 7, and you get 25.38. And that's our angle. Okay, so turn to your homework. We're going to get you started here. We're going to give you about 10 minutes. And you're going to turn to the spot that says solving right triangles. And the first 6 problems, you're asked to solve for a missing side. And then the next 4 problems, you're solving for a missing angle. When you get to the back side and you see the larger triangles that have all sorts of things that we're solving for, that's what we're going to do some notes on it right about, well, about 1:58. Okay, so we'll give you about 10 minutes here. Go ahead and see if you can work on those first 10 problems. I have the answer key posted right here. I'll come around and check to see how you're doing. Note again that the next 2 days you have time to ask questions and work in class.
Are we only finding the x? Or
Yes, you're only finding the variable that's listed. So here we want to find the arc length, and arc length S is the radius times theta. So in this case, S is the radius is 11, and theta must be in radians. So So you don't type in 315, you type in the radian, which is 7 pi.
Isn't it?
So you multiply that, you get S equals to 77 pi. It says round to the nearest tenth, so you can actually come up with a decimal approximation there.
So that's not the answer.
You should on your calculator then just go 77 pi. Well, you get the idea. And then in this situation, it says do not round, so you'd actually just leave it like, all right. On the back side, it says to find the area of each sector. And area formula is K equals 1/2 R squared theta. Again, theta must be in radian. Okay?
Yeah.
Love the flannel today.
Thank you.
Which one of this?
Oh. Reckon I like your flannel too.
Is girls basketball home tonight then?
Yeah.
Faribault?
Down with the Falcons.
Yep.
How are you doing? Against us?
Yeah.
How are you doing?
I'm good.
You have a great flannel today.
Thank you.
Remember this?
Yeah.
Okay. Any dubs on Fortnite this weekend?
No dubs on Fortnite.
Sorry about that, man. That's what I figured. I mean, if you would have played, you would have had
I would have had so many dubs.
Making sense?
Yes.
Gina?
Yeah.
How's your sister doing?
I think good. Started with her boyfriend.
No. Tell her I would love an email updating me on her life and how she's doing.
Okay.
Can you do that?
Yes.
Where's she at?
She goes to Riverland.
Okay.
Nursing.
It goes.
Or do I just?
Still, okay, I didn't know.
So I guess.
All right, good for them.
So 2.
How you doing, bud?
Yeah, 2.
Is it making sense?
I always do 3 though.
Okay, so in this situation, right here, notice how you have a side of 11, right? So that's the hypotenuse, so that will be longer. So you can tell that something's not quite right. What's not right is cosine. You chose the correct one, but cosine is not the hypotenuse or the adjacent. It's the adjacent over the hypotenuse. So this should set up not x over 11, but 11 over x. You see that? 11 over x. So then you cross multiply, come up with something slightly different. Making sense? Too easy, huh? What you doing? How are we doing? Looks good. I went to buy my pair of On Clouds.
Why are you too old?
Yeah.
Oh,
He talked me out of them.
why?
He said I'm too old.
He did not.
Yeah.
Doesn't seem like a very.
He said that I should get a pair of Brooks. He said that the On Clouds are super like comfy, but he said I've got plantar fasciitis. He said I need stronger support over a longer period of time. So he pushed me to the old man shoe category.
Kind of sad.
I did.
So you bought Brooks.
I bought a pair, but I brought them home, and then I looked on Amazon. I think I just get cheaper there. So I'm gonna get like last year's model, so instead of like 160, like 95. You know what I mean?
I tried to look for, I went up to the cities to the Prairie shows. They didn't have the ones I wanted either, so I used my gift card.
Good for you.
Mr. Dan,
Yes.
how you tell which is which on this one?
Okay, excellent question. So everybody has a little bit different way it connects with them more. So we'll see if this connects with you. See how it's 50.1? So they go straight across from that. That means that's the opposite.
Oh, okay.
So I always find it's easy to identify the opposite. Now I know if you want to cross with a 90 degree angle, that's always the hypotenuse.
So this would be adjacent.
Yeah, so I would just list the adjacent last. To me, that seems like the awkward one. About 3 more minutes, kind of work through some of these problems. And then we're gonna go to the next piece. Did you guys communicate last night about flannel piece?
We did not.
I was just gonna say I didn't get a memo. I could have worn flannel too, but
Sorry. Next time.
Mhm.
Oh.
Yeah, problem 2 and 6 are exactly the same, so sorry about that.
So when you're finding theta, it's a degree, correct?
Yes. Let's take another minute, and we'll kind of pull back to another piece. I got a certificate of achievement yesterday. I took a quiz online about internet safety security. So I don't click on like phishing emails and stuff.
Mhm.
Scored a 5 out of 5.
Nice.
Pretty proud.
Pretty good.
Yeah. I also took a test on the teachers being aware of students who are self-harming. I only got a 7 out of 10 on that one.
Dang.
But I retook it and I got a 10 out of 10 on the second time.
Yes, that's all that matters.
Yeah.
Never
I figured it out
is your
eventually.
best test.
Some of the questions were kind of, a little bit misleading, I felt, but. Okay, let's pull back. You want to be in your homework. So I'm going to bring you up to this spot in your homework. We're going to do example 1 and example 2. The differences in this situation, instead of being able to identify one part of the triangle, you want to be able to solve the entire triangle. Solving the entire triangle is going to be something that comes up multiple times in this class. And so this is kind of our first look at it. And the first thing we want to do is we want to draw a triangle that's kind of representative of the situation we have. I placed something there right away. And it is always going to be in the case in this section that angle C is always going to be the 90-degree angle. Very clear on that? Okay. Then A and B will be the other two angles. Since I see that B is 32, I'm going to choose to put B down there. But just to be clear, if you switched A and B, that shouldn't make any difference in your answers. Your triangle just might look a little lopsided, you know what I mean? Now, as far as the sides are concerned, the angles are always the capital letters. The sides are the lowercase letters. And if this is angle C, then this is side C. It is across from angle C. And so this would be angle A down here, and B would be over on the side over there. So very important that you make sure you know which side is which and which angle is which. Side C measures 8, and we can place that right there. Side C measures 8. So at this time, we have 3 parts that are given, and we have 3 parts now that we're trying to find. Parents, share with the person next to you which one of these 3 is easiest to come up with and why. Go, talk. Which one's easiest to come up with and why?
A degree, because you just have to do 180 minus
Or, you know,
5, 4, 3, 2, 1. Is it easiest to come up with the last angle or one of the sides?
last name.
Last angle, because all the angles of a triangle add to
180.
180 minus 90 is 90, minus 32 is 58 degrees. Excellent. So you so far have 1 out of 4 points on this problem for the test, okay? So let's get a couple more points. The other points are going to come by finding one of the sides. At this point, you have to make a decision. Nevaeh, would you like to be using angle A or B? It's up to you.
B, please.
She wants to use angle B, which is absolutely fine, okay? She makes a choice. She chooses to use angle B. I'm now going to decide what's opposite, adjacent, and hypotenuse. Obviously, this side is the hypotenuse. How about side B? Is that the opposite or the adjacent?
Opposite.
It is the opposite, and therefore side A is the adjacent. Now, pause. Everybody needs to understand that if I chose to work with angle A, then this side would be the opposite. Agreed? Okay, so that you have to understand that it matters how you choose to set up. That's why you have to make a choice. So she chose to work with angle B. Great, now she's going to make another choice. Nevaeh, would you like to find side B or side A?
A.
She wants to find side A, okay? So she wants to find the adjacent, and she's given the hypotenuse. She wants to find the adjacent, and she's given the hypotenuse. So sine, cosine, or tangent?
Cosine.
Cosine. So we set up the cosine of the angle, which is 32 degrees, is equal to the adjacent, which is A, over 8. I cross multiply. A times 1 is A. And I get 8 times the cosine of 32. 8 times the cosine of 32. Can somebody do that on their calculator for me?
6.78.
6.78, so says Miss Deming. Thank you very much. What's your middle name?
Lynn.
Lynn. Gilly Lynn. The same as Evie.
Oh.
Do you know how I remember that?
How?
Because I wondered if her name was short for Evelyn. And she said it's not. Her first name is Evie, but her middle name is Lynn. Ah, Evie, Lynn, Evelyn. Okay. All right. How are you going to find side B? Good. So you could use sine. You could say sine of 32 is B over 8. Can somebody think of another way to find B?
Tangent.
Tangent? Can somebody think of another way to find B?
Pythagorean theorem.
The Pythagorean theorem. If you have 2 sides, you could come up with the third side. Agreed? I don't care what you use. It's up to you. Pythagorean theorem, or I like the sine of 32 is B over 8. I just go to my calculator and I type in 8 times the sine of 32, and I get the grand total of 4.24. And you've solved the triangle. So you get 1 point for finding that first angle, and then you get an additional 2 points for finding that first side, and then you get a final point for finding that last side, okay? Now, I want to check the reasonableness of my solution. When I say the reasonableness of my solution, what I mean is that you have the largest angle, that should correspond with the largest side. And the smallest angle should correspond with the smallest side. You see that? Biggest angle across from the biggest side, smallest angle across from the small side. If that doesn't work out, something's wrong on your triangle, okay? All right, our last example, example 2. In this situation, again, we have a 90-degree angle. Everyone will have a 90-degree angle of C. Side A is 5 and side B is 12. You can put the 5 and 12 wherever you want, but I think it makes sense to put the 5 on the shorter side and the 12 on the longer side. If you mix those up, that's fine. Your triangle just look a little bit weird, but that's how I place it. Which is the easiest thing to find here?
Little C.
Yeah, side C. 13 because it's a, yeah, it's a 5, 12, 13, right? I mean, it's kind of handy to know those, right? Like they come on up, so. Great. Shoot, we're almost done. Like, this is quick. All we gotta do is find an angle and subtract from 180. So, Maddie, you get to choose. Do you want to work with angle A or B? It's up to you. She wants to work with B. So then we decide, do you want to use sine, cosine, or tangent? It's up to you. You choose whatever you want.
Cosine.
She's going to use cosine of B. Okay?
How'd you get the, because of the weird little things you memorized?
Yep. The weird, I see weird is kind of a stigma.
No, not
real
weird,
comfortable with
like.
it. I don't know. I think it's cool.
Weird.
Little things.
Like,
That was good. Wait, so if we didn't know those, we would use.
Pythagorean theorem. A
Okay.
squared plus B squared is C squared.
Okay.
But you are going to remember it because you're super smart. And you memorize all sorts of things for your current events and tests. So you can memorize this stuff too. Here we go. Cosine of B is equal to, I have adjacent over hypotenuse. So I have 5 over 13. But suppose Gina is like, no, I don't want to use cosine. I want to use tangent. Because tan makes me think of someplace warm and being in the sun. So she could have chosen tangent. She would be like, tangent is 12 over 5. And Brian's like, no, I don't want to use that. I want to use sine because it reminds me of sin and all the bad things I do. Okay, all right. All right. So then that'll be like 12 over 13. It doesn't matter which one you choose. Whatever you choose, you're going to come up with the same answer. It's really beautiful. You get second cosine of 5 divided by 13. And notice you get 67.38. Or suppose you chose to use tangent. And for tangent, you have 12 divided by 5. And suppose you use sine. So sine inverse, you would have 12 divided by 13. And I get 67.38 in either situation. 67.38. Subtract those two from 180 and you get 22.62 degrees. I probably owe an apology to Bryant. I don't think you're probably very simple.
I mean, I said I'm human.
No,
I wouldn't consider myself the worst person in the
well,
world.
like not as much as the debate. There you go. Hey, all the ones on the left-hand side set up like example 1. All the ones on the right-hand side, they set up like example 2. You might look at it and say, well, Mr. Gens, I already know how to do these. I don't have to do 6 problems. You do because you need to be fast with it because this is a foundational thing. We want to be able to do this pretty quickly as we move forward, okay? So you need the review and you need the practice. Tell you what, I won't give you any assignment tomorrow or on Thursday. How's that? And tell you what, I won't give you any homework for this weekend either.